Hi, Mr. Minnick here. I'm going to do some problems off of this computer number systems conversion worksheet number 2. I don't want to take your fun away from doing the 6 decimal to binary problems here, so I will propose that we do a problem in which we're taking the number 453 and we're converting it from decimal into a binary number. So here's how you do this. First you make a little cheat sheet for powers of 2. So there you have my cheat sheet. I have everything recorded from the power of 2 to the 0th, which is equal to 1, up to 2 to the 9th power, which is 512. So we ask ourselves, what's the highest power of 2 that divides into 453? Now 512 does not fit, but 256 does. And we set up that long division problem. And we perform the long division. 256 divided into 453. It fits one time, and then we find the remainder. Well, because of that because of that 1, we put a 1 in the column represented by 2 to the 8th, which I guess you could call it the 256th column in a binary number. And now with the remainder, we start a new long division problem, and we divide the next biggest number, power of 2, that we can fit into 197. Well, 128 does divide into 197. It divides in one time with a remainder of 69, and this 1 is put into our final answer here, which it happens to be in the 2 to the 7th column, which is the 128th column. We're finished now with 128 as a divisor, and we take the remainder, set up a new long division problem, and we ask again, what's the highest power of 2 that fits into 69? Well, it's 64. And it fits one time. Therefore, there's a 1 up here in the next column from left to right. This is the 64's column if you care. And there's a 5 remainder. That's a 4. So there's a remainder of 5. And we used up that 64. Now, here the problem takes a little twist. We set up a new long division problem with the remainder. You're seeing the pattern here. 197 goes up there as the next dividend. 69 goes up there. 5 goes up there. And what's the largest power of 2 that fits into 5? Well, it's not 32. So we have to represent that non-division as a 0 here in the 2 to the 5th column. And we ask then, does 16 fit into 5? No, it doesn't. So we put a 0 here in our answer into the 2 to the 4th column. And we ask, does 8 fit into 5? No, it doesn't. So we have yet another 0 up here in our final answer in the 2 to the 3rd column. And does 4 fit? Yes, it does. 4 fits into 5 one time. There's a remainder of 1. This 1 adds into the final answer. This is the 2 squared column. 2 squared is 4. We used up this 4. Does 2 fit into 1? We take this 1 and we set up a new long division box. No, 2 does not fit. So we have to put a 0 in our final answer into the 2 to the 1st column. Now don't forget to use up this 1 over here. 1 does divide into 1, and the remainder is 0, which means we're finished with the problem. And that 1 that we just successfully divided into 1, that gets added there to the end of this final answer. So there you have it. The decimal number 453 translates to the binary value 111000101. Now you can have fun with these 6 problems. Moving on and doing a octal problem, converting decimal numbers to octal. Now, I'm not going to do one of the problems that are on the worksheet. I'll convert 218, the decimal number, into its equivalent value in octal. Well, just so you think about this, mental checking, the answer should be a number that looks like it's bigger than the decimal number. So it's going to be like a 300 or a 4 something. It's going to be something like that. It's going to be a bigger number. It's going to be equivalent to 218, but it just looks bigger because we're in octal. Well, 218. Make your little cheat sheet. There's my cheat sheet for the powers of 8, and we ask what's the highest power of 8 that fits into 218 that we put here in our long division box. It's 64. So 64 divides into this how many times? Hey, this is an interesting variation because unlike the previous binary problems, we actually get a number that's above 1 here. 3 times 64, 192. Subtracting, getting the remainder, and it's 26. Put that 26 in a new long division box. Put that 3 up in the final answer. That 3, by the way, is in the 8 squared column, or also known as the 64s column. And what's the next highest power of 8 that fits into 26? Well, 8 itself. 8 fits in there 3 times with a remainder of 2. So that 3 also goes into the final answer. It's in the 8 to the first power. And we take this remainder of 2 and we proceed. Does 8, we used up this 8, and so does 1 divide into 2? It sure does. It fits in there 2 times. And we achieve the division of 0, or the remainder of 0, which means that we're finished with the problem. But this 2 does go into the final answer, into the ones column. So your final answer here is 332 in binary, or in octal. Okay, let's do a hex problem. Okay, for this last type of problem, I'm going to actually do problem number 15. So we have a decimal number 2,876. We want to convert it to base 16. We need a cheat sheet. So here's my cheat sheet. 16 to the 0 power is 1, 16 to the first is 16, and 16 squared is 256. And I think I need to go higher than that, so 16 cubed is 4,096. Well, 4,096 does not fit into 2876, so we cross it out. We set up our long division problem as we've been doing on this worksheet before. Does 256 fit in? Yes, it does. How many times? Well, let's figure it out. Drop down that 6. 256 fits in 316 one time. And the remainder here to this is 60. But this 11, if you follow the examples above, you'd put the 11 in the final answer, but you can't put a 2-digit decimal number in the final answer here for a hex question. What you need to do is look at your other cheat sheet. The cheat sheet that I often write down on a test paper as soon as the test is distributed, if I had to do some hexadecimal conversions, I just plot out A through F and their corresponding decimal equivalents. And because we got the number 11 here as our quotient, B, the letter B, first appears in the 16 squared column. Now we take this remainder 60, we ask ourselves the famous question, what's the next highest power of 16 that fits in there? We used up the 256, by the way. It looks like 16 fits into 60. And how many times does it fit? 4. No. That's too much. 3. Rusty on my long division. 3 16s fit into 60. And that answer comes out to a remainder of 12. uh, the number 12, I'm sorry, the number 3 goes into our final answer here in this column for 16 to the first. And this 12 is used in that it's set up as our new problem, and we ask, what's the highest power of 8 that fits into 12? Well, 1. 1 goes in there 12 times, no remainder. We're finished with the problem, and this 12 cannot be just simply written in here. No, that can't be done. So we have to convert 12 using this other cheat sheet. It's really the letter C.